pretty close.
This is a stationary electric super slicer. It comes in a portable unit, also comes in diesel and gas. On this one here is electric. We have a 15 horsepower electric motor, and we're using a gear pump. This is the starter panel for the electric units. It has a start and stop button. When we open it up, we have a starter. Your wires from your power source come up and go into the top three here, and your ground goes over to the other side. We have a transformer that brings the power down for the starter down to 110 volts for the switch. This is the diesel version, a 23 horsepower Isuzu engine. This is the engine hood cover, which folds down, where you will find the engine operator's manual. Here's our fuel filter, our oil filter with a dipstick next to it, our air filter, our ignition panel, which has warning lights and an automatic shutdown, and the hour meter. This comes with a 2-inch ball receiver and a 7-way RV electrical plug. The jack is a 1,500-pound top line swivel jack. This is our oil reservoir. We run Dextron 3 or something of a similar viscosity. This is a hydraulic oil sight gauge. Oil levels should be between low and high marking for normal operations. This is a fill cap. Over here is our filter. You take the 4 bolts out, lift the cap off, and pull out the element. We come around here, we have our control levers. The super slicer has 3. One raises the height of the tire where we're going to cut at it. The next one is the cutting, go around, and the other one is to lift the tire up into the cutter. Down here we have a flow control. It has an adjustment on it that we adjust to 1,000 pounds. It regulates the pressure on the cylinder bringing the tire up into the cut. When adjusting the pressure on the machine, this is the main pressure relief valve. To check it, we go over here to the gauge, and it reads 2,500 psi is what it should read. If it's below that, then we come over here and adjust this valve. To adjust it, we take the cap off, loosen the jam nut, and adjust the screw. As you push the screw, turn the screw in, it increases the pressure. You just screw out, it decreases the pressure. And this is all checked by pulling on the lever for the tire lift and bottom the cylinder out. At that point, you can be able to read the gauge. This is a pressure reducing valve. It is supposed to be set at about 1,000 pounds of pressure. It is used for when the tire is brought up into the machine, up to the cutter, and the amount of force that is being put on the cutter as it comes up. To adjust it, we loosen the jam nut and adjust the screw in and out. As you go in, it increases the pressure. As you screw it out, reduces the pressure. This is the cutting mechanism of the machine. We have the main cutting arm with a cylinder that lifts it back and forth. We have the main cutter that has a slot cut in it. We have the roller pin that holds that in with a grease zert on the end of it. We have a roller here. This whole mechanism slides up and down. That adjusts the height of the tire where you're going to cut, either next to the bead or anywhere up on the sidewall. This roller here is on there to keep the tire from going sideways. And that cylinder is a cylinder that adjusts the height of the tire. This is a blade assembly that does our cutting. It consists of our blade and a hydraulic motor. We have an upper drive and a lower drive, which is a double gear drive. And we have a bearing on the bottom to hold the back of it. This whole assembly has 6 bolts on the back side of it. It's adjustable up and down and to tilt to match up with the slot on the main roller. To adjust this, or to replace the blade, what we would do is we would take the 2 bolts out of the top of the motor, relieve the set screw there, down here, and also on the bearings down below. We would lift the motor out and then pull this assembly out of it. Then we would take the 3 bolts out that hold this unit together, and inside there is a shaft that goes from the bottom of the bearing to up just close to the shaft on the orbit motor. That would all slide out apart, replace the blade, and then put it all back together. As you put it back together, turn it to adjust it so that the ribs here and the ones down here don't line up. As you can turn it to different spots to where they won't line up. That helps to take the chatter out of the machine when it's running up against the steel roller. When replacing the blade and adjusting it to the right angle, after it is assembled into the housing, bring the arm up into the blade. When you get close, make sure you check to make sure it's sliding inside of it, and bring it all the way in. The blade should center itself in the center of the slot. And also the roller should come up against the drives. If it does not come up against the drives, then we would back it back out, loosen the bolt on the cylinder, and turn the shaft. As we pull that in, it'll pull the drive and roller closer together. The other mechanism is our lift, and that slides up and down to adjust the height of the cut on the tire, on the sidewall of the tire. And then we have the rotation of the cutter, and this is the direction that it should turn. For daily maintenance, we need to grease this grease zert at least once a day, along with a slide grease zert once a day. There are 2 more grease zerts on the bearings. Another grease zert up on the bearing of the drive once a day. This is a tread cutter attachment. It's available on the sidewall cutter and the super slicer. The hydraulics on here are run by an orbit motor connected to the blade. Here we have the cutter roller. That's our shield. Here we have our valve. This is a relief valve that's set at 2,500 psi. We have 3 grease zerts. One is here. This one should be greased daily. We have another one back here on the shield. Could also be greased daily. And the one on the pivot down here, greased daily. The roller is designed to lift the shield up, but also designed to help flatten the tire out as it comes through the machine. For certain tires, you would need to add this weight to help flatten the rubber out as it comes through. Machine has a two-hand controls, so it takes both hands to pull up on it. That starts the hydraulics to cut. And as you push it in, it cuts the tire. Always refer to your manual for your operational and safety questions.